Hello viewers, I'm Kausalya. Today we are going to solve problem 3 related with ABCD parameters. The problem is find the ABCD parameters for the network shown and this is the given network. So first we start with writing the general equations. So V1 is equal to A V2 minus B I2 and I1 is equal to C V2 minus D I2. So as a first step, we are going to find the values of B and D. Therefore, here we are going to make the value of V2 as 0. Because once V2 is made 0, this term will be 0, this term will become 0. Therefore, we can easily find the values of B and D. So how to make the value of V2 as 0? So from this diagram, you see V1 is here and V2 is here. So how can we make a voltage value 0? Just by short circuiting. Therefore, here short circuiting the terminal to 2 dash. So when you short circuit the terminal, what happens? Obviously, the value of voltage will become 0. So just we are redrawing the circuit. So here we have short circuited the port to 2 dash. So now when you rewrite the equation, you see here V2 becomes 0. Therefore, V1 is equal to minus B into I2. Therefore, the value of B is minus V1 by I2. So, now we are going to find the value of V1. So, from this circuit, V1 can be written as V is nothing but it is generally given by I into Z. So, here we have V1 and I1. So, we have to find the value of the impedance. So here this is the current I1 and this current when it reaches the node here, what happens? It gets divided into 2. Again, this current when it reaches this node, what happens? The current will directly flow through this short circuit path and it won't enter this 1 ohm resistance because the current will always select the least resistance path. So here the current that flows through this 0.5 ohm will directly flow through this short circuit path and it will return back like this. Therefore, the value of impedance is, you see, at this node, these two resistors are parallelly connected. Why parallelly connected? Because the current gets divided. Therefore, these two resistors are connected in parallel and that combination comes in series with this 2 ohm. Therefore, here while writing expression, you see V1 is equal to I1 into Z. So, initially you see these two are connected in parallel. Therefore, 0.5 parallel with 0.5 and this combination comes in series with this 2 ohm. Therefore, 2 plus. So, this is 0.5 parallel with 0.5. So, when you solve this, what happens? You see, here impedance is 2 plus 0.5 parallel 0.5. Therefore, here the equivalent impedance is R1 into R2 divided by R1 plus R2. So, here this 2 plus, here it comes as such. So, when you solve this, what happens? Here we are getting 0.25. So, 2 plus 0.25 gives 2.25. So, this is the value of your impedance. So, when you substitute this value of impedance in the equation, here we are getting V1 is equal to I1 into 2.25. So, now we have calculated the value of V1. The next step, we are going to find I2. So, to calculate I2 here, we are going to use the current division rule. So, what is the current division rule? The current division rule is total current multiplied by opposite resistance divided by total resistance. So here we are going to find I2. So here I2 is given by, here what is the total current for this circuit? It is I1 and the direction of I2 is opposite to that of I1. Therefore, here we are writing as, you see, I2 is equal to minus I1 into opposite resistance. So, what is the resistance that is opposite to I2? It is 0.5 divided by what is the total resistance? It is 0.5 plus 0.5. Therefore, here I2 is given by minus I1 into 0.5 divided by 0.5 plus 0.5. So, here 0.5 plus 0.5 gives 1. Therefore, I2 is given by minus I1 into 0.5. So now we have calculated the value of I2 and we know the value of V1. So just substitute it here. B is given by minus V1 by I2. Therefore, minus what is V1? V1 is I1 into 2.25 divided by I2 is given by again minus I1 into 0.5. So when you substitute, you see finally here we have the answer as 4.5. So the value of B is given by 4.5 ohm because it is the ratio of voltage to current, it is impedance. So here it is given by ohm. So what is the expression for D? You see I1 is given by minus D into I2. Therefore here again we are just rearranging, right? So here 1 by D is given by minus I2 by I1. So just now we have calculated the expression for I2. So just substitute it here. So finally we end up with 0.5. So 1 by D is 0.5. Therefore, the value of D is just you have to take reciprocal. So 1 by 0.5 that gives you 2. Therefore, here the value of D is 2. You can do it directly. Right, no need to take reciprocal and then proceed. As I have written, just I have completed like this. From this step, you can directly go by D is given by, just move this I2 here. So you will be having minus I1 by I2. So just substitute the values and again you will be ending up with the same answer 0.5. Since it is the ratio of current, there is no unit. Right. So next we are going to find the remaining two parameters. So again when you look at the basic equation, so here we have to make the value of I2 as 0 to calculate the values of A and C. So how can we make the value of I2 as 0? Just by open circuiting. So here when you open circuit, automatically I2 will become 0 because I2 is the current that flows through this port to 2 dash. Therefore when you open circuit this port, I2 will become 0. So when the value of I2 becomes 0, the value of V1 is given by V1 is equal to A V2. Therefore A is given by V1 by V2. So again we have to calculate the value of V1. So V1 is given by I1 into Z. So here we have to calculate the total impedance. So here you see this current when it reaches this node, it gets divided into 2 and again the current flowing through this 0.5 ohm will flow through this 1 ohm. It won't get divided at this node. Why? Because here there is an open circuit. So current will never flow through the open circuit path. Therefore the current flowing through this 0.5 ohm will flow through this 1 ohm. So what does this mean? This means that this 0.5 ohm and 1 ohm are connected in series. So while writing the expression, you see these two resistors are in series. So 0.5 plus 1. Right, when you solve, you see here we are having this 2 ohm and here we are having this 0.5 ohm. Now these two resistors are connected in series. Therefore what will be the equivalent value of resistance? 1 plus 0.5 will become 1.5. Now these two resistors are connected in parallel because you see the current when it reaches this node, it gets divided into 2. Therefore, you see 1 plus 0.5, this combination gives 1.5 and this 1.5 is in parallel with this 0.5 ohm. So this is what I had written here. And again, this combination, again when you solve this, you will be having 2 ohm here and these two resistors will combine and they will form a single resistor. So finally, these two resistors will be connected in series. So here first we solve this combination. So 0.5 parallel with 1.5. So 0.5 into 1.5 divided by 0.5 plus 1.5. So when you solve this, you see here we get 2 plus 0.75 by 2. So once you solve this, here we have 0.375. So 2 plus 0.375 gives you 2.375. So now we have calculated the value of Z. So we can directly substitute it here. So V1 is given by, V1 is equal to I1 into Z. So here this is our expression for V1. Now we are going to find the value of V2 because A is V1 by V2. So here you see, when you look at this diagram, V2 is nothing but, what is V2? V2 is nothing but, it is the voltage impressed across this resistor 1.5 ohm. Therefore, V2 is given by current flowing through this 1.5 ohm resistor. Yeah, I'm sorry, because this is our original circuit, right? So this is the voltage V2. So this V2 is nothing but it is the voltage impressed across this 1 ohm resistance. So here V2 is given by, actually this is a modified circuit, okay? I'll explain this. So V2 is nothing but current flowing through the 1 ohm resistor multiplied by 1, because V is nothing but I into R. Here, so what we have done is, I had combined these two resistors together. So 0.5 plus 1 are in series, right? Therefore, 0.5 plus 1 gives you 1.5 here. So we are assuming let Ix is the current that flows through this 1.5. So here the thing is, that is why you see here the current flowing through this 0.5 ohm flows through this 1 ohm, because they are connected in series. Just in order to simplify the calculation, I am combining these two resistors together. Therefore, here when these two resistors are together, the net value is 1.5. Therefore, here again Ix is the current that flows through this 1.5. So V2 is given by Ix into 1. Because the value of resistor here is 1 ohm. Am I making things clear? You see, just for our calculation, I am combining these two resistors. But this is our original circuit. So this is V2. Okay, the voltage at this part is V2. So here this V2 is nothing but this is the voltage impressed across this 1 ohm resistance. Here, so again you see Ix is the current that flows through this 1 ohm. Similarly, the same current flows through this 0.5 ohm. Why? Because these two resistors are connected in series. In order to make our calculation easier, I have combined these two resistors together, because it will be easy to find the value of the current. Or else if you have 3 resistors like this, it will be a bit confusing. So what is V2? V2 is nothing but Ix into 1. So this is what I had written here. Now we are going to find Ix. Just to find Ix, here I had combined these two resistors together, because same current flows through these two resistors. So here our circuit looks like this. So how to find Ix? Again by current division rule. So what is the total current? Your total current is I1. So total current into opposite resistance. So the resistance which is opposite to Ix is 0.5 divided by total resistance is 0.5 plus 1.5. So this is what I had written here. Again, when you simplify, we end up with Ix is equal to 0.25 I1. So now V2 is Ix into 1. So just substitute the value of Ix here. So V2 is given by 0.25 I1. Therefore, the value of A is V1 by V2. So V1 is given by I1 into 2.375 and V2 is given by 0.25 I1. So when you solve, finally we have the answer as 9.5. Again, you see this is a voltage gain ratio between voltages. So we don't have any units here. Finally, we are going to find the value of C. So C is nothing but it is the ratio of I1 by V2. So V2 is nothing but 0.25 I1. So finally, we end up with the answer as 4. And here the value of C is given by 4 mho, because it is the ratio of current to voltage. And finally, we can have a check, that is AD minus BC is equal to 1. This suits for all transmission parameters. So when you substitute the values, you see A and D 9.52 and B and C as 4.54. So when you solve this, here we have 19 minus 18 finally, which is equal to 1. Therefore here, that is all the 4 parameters absolutely sets this equation. Okay, they get tallied here. Therefore our answer is perfectly correct. So that's all. If you have any doubt, let me know in the comment section. Thank you.